I welcome all of you to a small session in electrochemistry. In electrochemistry, we come across two types of cells. The first variety is called electrochemical cells, and the second variety is electrolytic cells. Well, electrochemical cells are known as commonly galvanic cells. For example, your Daniel cell is in this category. Your voltaic cells, for example, Leclanche cell. Practically, the dry cell which you are using, all are in this category. And mainly in electrochemical cell, you carry out a reaction, rather spontaneous reaction, the reaction that happens all by itself, to produce electric current. So if a reaction is happening by itself, which is a spontaneous reaction, gives free energy change, delta G is negative in this case. Whereas in electrolytic cells, there are many variants. For example, you use a Downs cell to produce sodium metal. Something like Kastner-Kellner cell, which is used to produce NaOH, and there are so many such cells used in bringing about a desired reaction. Using electric current, we consume electric current in electrolytic cell to bring about a non-spontaneous reaction. It means normally this reaction will not happen by itself. Now you are forcing this reaction to happen by using electric current. Therefore, in this case, delta G is positive. For example, naturally Na plus has no interest to take electron. Now, if you want Na plus to take electron, you have to apply a lot of potential difference and you have to use a specially designed cell. So, you are making a otherwise non-spontaneous reaction to happen. Naturally, Na wants to lose electron under suitable conditions. Now you are making reverse. So delta G is positive. Now, this electrochemical cell often requires a salt bridge, or it requires a porous partition. Such requirement is not there in electrolytic cell. Well, always you should notice one interesting thing. Anode, at anode in electrochemical cell, there takes place oxidation. And anode in electrochemical cell is a negative terminal. Cathode in electrochemical cell is a positive electrode, and there happens reduction, that is gain of electrons. Notice here also at anode oxidation happens in electrolytic cell. At cathode a reduction happens in electrolytic cell, as in this case, but here anode has a positive sign and a cathode has a negative sign. Notice that in electrolytic cell, the negatively charged anions like X minus go to anode and they tend to lose electrons, thereby undergo oxidation. The X minus ion goes only to a positive terminal. Therefore, here anode is a positive terminal. Similarly, in this cathode is a negative terminal. Cations go to cathode. Remember, always cations go to cathode. That is a positive ion like Zn plus 2 or anything can go to cathode. There it will gain electrons to become zinc in this case. So naturally Zn has no tendency to gain electrons. Plus 2 cannot become zinc by itself if there is any competitor. But this reaction you are forcing using electric current in an electrolytic cell. Notice here anode oxidation, here cathode reduction, but anode has a negative charge here. In electrochemical cell, cathode has positive charge. Notice always electrons flow onto chutney from anode to cathode. Even in electrolytic cell, electrons flow from anode to cathode in external circuit. Always this is the flow direction of electrons. And the current flow, conventional current flow direction is reverse to above in all cases. So it should burn in your mind. Electrons are flowing always from anti to chutney. AC, remember AC, alternating current, anode to cathode. And in the electrolytic cell, electrons are entering at a cathode. Electrons enter into electrolyte. Cations go to cathode. And cations have positive charge, cathode has negative charge in electrolytic cell. Electrons are entering into solution, into electrolyte at cathode. And they are coming from anode. This is the flow direction of electrons. And the anode is a positive terminal. It is becoming positive because constantly electrons are pumped out of it. And it is a negative because electrons are getting accumulated and entering into solution. Remember, cations go to cathode, anions X minus will go to anode. There it will lose electrons and electrons quickly travel through this. Again it will become positive. So always anions go to anode, cations go to cathode. In electrolytic cell, chemical changes are happening in electrolytic cell by consuming electric current. Whereas here chemical reaction is happening by itself to generate current. Notice that when you are talking of an electrochemical cell, what is the useful electric current you can get is measured in terms of electromotive force or standard cell potential. Always standard cell potential is given by E right electrode minus E left electrode. Notice that if you are not putting standard conditions, generally standard condition means temperature is fixed as 298 K and concentration of ions maintained at unit activity or 1 molar concentration. 1 molar is sometimes called unit activity. And if you are pumping hydrogen gas or any gas, that is pumped at 1 atmosphere pressure or 1 bar pressure. So under standard conditions, if you are measuring the cell potential, that is equal to E right minus E left, always the EMF electromotive force or cell potential can be measured using a voltmeter that is connected parallel to circuit. Okay, sir? When you are talking of electrochemical cell, often if you change the temperature, pressure, concentration conditions, cell potential is given by Nernst equation. What is Nernst equation we see in the next video, but at the moment I'd say you require Nernst equation to understand the cell potential. Notice individual electrodes potentials can be determined using a sheet. She is standard hydrogen electrode whose potential is taken as 0. With reference to she, always the right electrode has a higher electrode potential than the left. If you take zinc and copper, zinc is having a negative potential and that is the loser of electron. Losers are written in the notation left side. After losing it gives Zn plus 2. This is called interface. This is called salt bridge. That will help the smooth flow of electrons by dispersing the accumulated ions. The zinc electrode is kept in contact with the copper electrode. This is the left electrode because it is losing electrons. It is the right electrode that is gaining electron. And cell potential is equal to the difference between the electrode potential of right minus left. All this Nernst equation necessitated in case of electrochemical cells. But in electrolytic cells, you require Faraday's laws to know mass of or the relation between mass of the elements produced and the strength of the electric current and the time during which it is maintained and on the equivalent weights of elements produced. You require Faraday's laws to understand the relation between masses of different elements produced, the current strength that you maintain and the time during which you maintain the current, and the equivalent weights of different elements produced, how they are related is given by Faraday's laws. You require Faraday's laws to decide the amount of product you get. But in electrolytic cell, one point I should say, if you have different ions with different electrode potentials, you have X minus, Y minus, Z minus, different minus ions. Always minus ions undergo oxidation to give say X, Y, Z. Then who will first lose the negative charge? That which has less discharge potential is readily losing the negative charge or positive charge. Nowadays we are not using the term discharge potential. Instead we are using standard reduction potential. The fellow that has high standard reduction potential will readily gain electrons in A plus, B plus, C plus. If this B plus has highest SRP, first it will gain electrons. So always electron gaining happens to that electrode which has highest SRP. Therefore, electron loss happens to that fellow which has least SRP first. So, we always use SRP standard reduction potentials to measure the ease of a certain oxidation or reduction in electrolytic cell when there are different ions. For example, if you have sodium ions and H plus ions in water, when you are passing current, the H plus will take electrons first to give you hydrogen gas, but not sodium, because the discharge potential of H plus is less. In other words, the standard reduction potential of H plus is more. Whatever that has high standard reduction potential is reduced first. Similarly, if we have sulfate ions and chloride ion in aqueous solution, who will lose electrons first? Means the chloride ion will lose electrons first. The reason is the chloride ion has lower SRP. Fellow with low SRP will lose first. So we always try to explain the feasibility or the preference of the electrode reaction based on SRP. This is the input related to these two cells. Hope you understood.